Hello and welcome to the next episode of the GTK4/GObject tutorial. I'm not going to number the episodes anymore. I'm simply going to talk about what we're going to talk about and talk about some special topics going forward. So today we're going to discuss two topics, interfaces in GObject and list models, which are a type of interface that's already been predefined through the GIO subsystem of glib. And so what we're going to do is make our own list model interface. Now, what is an interface? Well, we talked about GObject types as being final or derivable. A interface is basically a set of subroutines or methods that are on a vtable, and they're not defined. So it's up to the implementor to define what those subroutines actually do. So you may wonder, why do this? Well, the idea is that it's often useful to have a defined way in which input will be given to a subroutine and output will be output from that subroutine, but without having any specific way that that's done. It can be completely behind the scenes, up to the implementor as to how to do that. So an example of this for me, and we won't be defining an interface today, we'll only be implementing one, but in my program that I'm working on called ghex, which is a hex editor, I wanted to provide multiple different backends in terms of reading files, writing to files, and editing files. And you can imagine that there's many different ways that could be done. And I wanted to be able to have different backends. So for example, if the Linux system supported memory mapping files, I wanted to be able to do that in a way that memory maps the files and then reads, writes, and edits them. But then on Windows, for example, you would need just to come up with a different way in which that's done behind the scenes. So that allowed us to have a default fallback backend that just used the C standard library to read the whole file into memory and edit and read and write to files in that way, which is obviously not ideal, but at least gives that the interface at least gave flexibility to be able to do that. And so that's an example of interfaces being useful. One type of interface rather that's coming up a lot more in GTK is called a list model. And so a list model is basically a generic it's an interface, but it's basically a way to have a generic type of list, type of data structure that the interface itself doesn't care how that's implemented. And so if you see here, there's no GListModel new you'll see here in this list of functions, because you can't just create a list model. You have to create an object that is able to do all of these things, which means it implements the interface. So with a list model, you are basically able to create an object yourself that is able to maintain a list of items, and your object needs to be able to do all these things. So it needs to be able to get the item type, it needs to be able to get the number of items, it needs to be able to get an item at a particular spot. Don't worry about GetObject. That's actually just for language bindings. And then this is also not part of the interface itself, but that's a way to emit a signal that something's changed within the list model. And so if we actually scroll way down to the bottom, you'll see here struct GListModel interface. This is the virtual function table that we need to be able to implement ourselves by creating subroutines that fit these prototypes. Okay, and so luckily with GObject and the macros, there's convenient ways of doing this. So what we're going to do is create something called a demo list model, which will be a GObject that will implement the GListModel interface. So let's just get right to it. So again, all this will be on the GitLab repo. I'll provide a link in the show notes. So let's open up our files here. We've got our demo listmodel.c. We've got our demo listModel.h, and we've got our main.c file, which will just do a very basic demonstration of the object that we create. So as per usual, you start with the .h file, and again, for consistency, we're using demo-list-model.c and demo-list-model.h, just as we did with any other GObject. And so we got our pragma once, just as we did before. We need to include glib/-object.h because this is not going to require a GTK, this list model, so we're going to have to manually pull in these header files, which GTK would have done for us, but because we're not in GTK, we have to pull them in manually. So we've got our gbegin decals, gend decals, same as before. We've got our demo type list model is defined as the get type, exact same as creating anything else that we've done before. In fact, everything in this header will be exactly as has been done with any other GObject. Nothing special with relation to interfaces is done in the header file. So you'll see we've got something very familiar here in terms of creating a final type. It's called a demo list model. You create a demo list model, right, using the demo list model new. Remember how I said before, there is no GListModel new. So we're going to create a type of list model that anybody can create by using our new constructor method. And list models always have to contain GObjects within them. And so what you typically do when you're creating your own is you have the new function or the constructor have the user tell the demo list model what type of objects do we expect to see in this list model. And you cannot mix and match. It has to be one type. And so what we're going to see later on is that we have some safeguards in place to make sure that the user actually gave us a valid a GObject. One thing that you'll find, and we've talked about this a little bit before, is that there's a lot of things in glib2 that look like GObjects because they've got the new, they got the unref, they've got reference counting in many instances, but they're not actually GObjects. They're either a GType instance or they're their own thing, and so that can be kind of confusing. But we'll just deal with things one step at a time. And you'll note that the list model interface does not actually require a subroutine to add an item to it. But if we're going to do a demonstration, we have to be able to add things to our model. Otherwise, we'll not be able to even demonstrate, getting the number of items, getting an item, and so on and so forth, right? So we're gonna create a customized subroutine called demo list model append, which will take our object as the self parameter, and then it'll take a G pointer to the item that we're adding, which will actually have to be a GObject, but we're just calling it a G pointer so that you don't have to cast it, which is kind of annoying in C, and so that's the way that we're going to do it. Okay, so that's the H file. Now how do we actually create this thing though? So we go to our C file, go to the top. So we're going to include our demo list model.h file, and again, don't forget that even though we're implementing an interface, we're still creating a GObject, and it's a final type. So you're going to notice that there's a lot of similarity to what we've already done. So we're going to create an object with properties. It's got one property. The only property that's going to have is what is the GType, like what type of object are we storing in this thing. So nothing is different about this, but we do have to predefine what's called an interface init function, and we have put a forward declaration here, and I put a little note to myself. We'll test this a little bit later to see if deleting it breaks. It probably will, because you'll see in a moment. I think they're going to expect a forward declaration, but I could be wrong. We'll see. And then you create the object itself, same way we always did, with a struct underscore thing. The parent instance will be a bare GObject. So you put that. Remember, reality check again. Don't put the star there. If you do, you're going to have some big troubles later on. We're going to have a GType, which is basically a number, as we've discussed before, which is going to store the type of object again that we're utilizing in our list model. And then we're just going to create a list model that's a very simple wrapper around a type that already exists in glib2, which is called a g-pointer array. Now, a g-pointer array is not a g-object itself, and so that is something just to be mindful of. So when we do this thing. So the next thing where things are different from before is instead of doing a plain old g-defined type, we now have to do what's called g-defined type with code. And so the first three parameters are the same as they would be in a regular g-defined type. But then the fourth parameter, you can add code. And you don't have to worry too much about what kind of code you can add, except that just know that when you're implementing an interface, you use this macro, and then you follow it with this macro within it, which is how you implement the interface. You do g, implement interface, the type of the interface, which is a list model, and then you specify your customized interface init function, which is a little bit like a class init, but it's specific to interfaces. And again, we'll take a look at what that looks like. So our property setter is nothing really new, except we need to use the g-value get GType function in order to grab rather a g-type from a g-value. But it's nothing should be too surprising about that. We're not using explicit notify, as you'll see. We don't have to omit. We don't have to do notify by pspec. Just because it's one property, and you can't really, you'll see in a moment, you can't do too much with it anyway, so I didn't bother defining separate methods, separate subroutines rather for those, and using explicit notify. So the get property, again, we only have one property, it's the type. You use the g value set GType setter in order to plot our GType into the g value. Nothing surprising there. I'm just going through it so that you see. Dispose function. It uses. Actually, let's work a little bit. Let's get to that in a moment. So, we got our init function and our class init function. So let's start with the init function first because it's a bit easier to understand. So, in order to create our pointer array, we use the gPointer array new with free function. And then the first and only parameter that it takes is when you destroy the pointer array, what if any function do you want to run on the guys in the array to free them? And because we know that we're ultimately going to create an array that has only g-objects in it, we're going to use the g-object on ref in order to destroy them. Right. So class init. Dispose, set property, get property, same as what we've seen before. But I will go over a couple things in the paramspec that we create because it might be a little different than what we've done in the past. So, okay, great. So we're going to create a g paramspec GType. Its name is going to be type, null and null for the nick and the blurb. We don't do that anymore. Then what it wants is, and this is actually kind of useful, I would think, is they want to know, look, what's the base type of guy that you want to be able to take for this parameter? And we know that when we're implementing a list model interface, it needs to have g-objects at least in it. So if somebody tried to use like a g-type that wasn't a g-object, then it wouldn't allow them to do that by using this paramspec. So we're going to use g-type object to ensure that that's the baseline. You can't use the types that go below that, or that are not derivative, rather, I should say, of a g-object. And then what are the flags? Because we only have one, I didn't create a separate variable for it. Now, let's work backwards. It's construct only. Why is that? Well, because you can't go ahead and change around the type of object that the list model can hold once it's been created. You got to tell it once and for all when you create it, what kind of object will this have in it? And that's it. You can never change the type again after that. You have to create a new instance. You have to create a new demo list model that holds a different type of object if you want to do that. So it's read-write, which is a bit confusing because you won't be able to write to the property except for that very first time. But that counts effectively as as being able to write to it, because you have to write to it upon construction, right? And so ultimately you can write to it the one time that you construct it, and then otherwise you can only read from it, right? And then static strings is boilerplate. I don't think I've ever not done that. Maybe it's useful for language bindings, but who cares? So then we use our standard GObject class install properties function to install our properties, which is just the one in this case. Right. So let's look for our interface init function. Right. So here's where we actually go ahead and tell GObject that okay, we know that the types of we know that the function pointers that are in the v table are these guys. So we need to map those to actual subroutines that follow these prototypes, right? So this is cut and paste from the documentation. So we've got get item type, you see here, get n items and get item. Those are the three function pointers that we need to give real functions now, okay? So first, again, this is boilerplate. It has our own name, which is GListModel interface init, but any standardized interface init function always takes the blank guy that you're implementing plus interface. It would be kind of like blank guy plus class when you're dealing with a class, and then iface is kind of the standard short form for that. And so then what you do is you go iface arrow all these three guys and define them to be actual subroutines that fit those prototypes. And then if you go to those one by one, get item type, they're actually pretty easy to implement, because get item type, literally all we need to do is just return the GType that we've already stored in our structure. So that's easy. But how do we get the n items? Well, because why is it doing that? Because we're wrapping a G pointer array, all we need to do is use functionality that we already have through that data structure. And the way that you do that with the G pointer array is that we have direct access to the structure, right? And its len or length member is already a GUINT. So all we need to do is do return self arrow r, which is our pointer array, arrow len, because we have direct access to that member. Easy. And then we need to, this is probably the most, in a way, the most complicated one, which is get item. So what we need to be able to do is fetch the item, which we know has to be a GObject, right, at the position that's requested. But the documentation says that a get item implementation has to be transfer full, meaning that you need to put an extra ref on the object, return it to the user, and then the version that they get, they're responsible for freeing it. And so you can't just do return you can't just do return G pointer array index self arrow r position, because then it will hand out a copy that's owned by our pointer array, and people reading the documentation will say, oh, it's transfer full. So then when they're done with it, they'll destroy it, but they shouldn't have destroyed it because it was the one and only copy that we had. And so it's important that you follow the documentation and do it right. So we could have done this as a one-liner, but I broke it up a bit just to make it easier to read. So demo list model star self is equal to, you just do our standard casting macro on list, which is a variable for the list model. Because we implemented the interface in our object, we can actually cast from the interface to our guy, which is pretty cool actually. So we do that right here, and then we can use self as we always do, right? And so to grab the object, it doesn't have to be obtained as a GObject star, because GObject ref technically takes a G pointer, but there's no real reason to to not just create it as a GObject in this instance. And gPointerArrayIndex is built into gPointerArray. It's basically a function style macro that returns a pointer to the element requested at the position that you requested. So you just do gPointerArrayIndex self arrow r position, which is coming from this parameter right here. Fairly straightforward. And then we've got our customized function, which is GListModel append. And just to keep things simple, we're not going to allow for people to add, remove, change, reorder, anything like that in our list model. All people can do is add to it, just to keep things super simple. So we don't have to follow any template for this. So what we're just going to go ahead and do is create a function that takes excuse me, our guy as a self parameter and a g pointer to the item that they're trying to add, and then we're just going to add it right to the end of the list model. And so what we're going to do is we're going to add a gReturnIfFail check right here, because this is public API, right? So whoops. We want to make sure that people that are library users are not doing the wrong thing. And so we're going to make sure that the item that's passed is actually a GObject, and otherwise it's going to throw an error. And then we're then going to define the position, which we're going to need so that we follow the format that the list model interface requires. And just as we saw before, we're going to grab that by going self arrow r arrow len. And the reason why we're doing that is because if you think about it, right now the length, the first time you ever add an item to it, the length is going to be 0. And so the length will equal the position that the new item will be added at, right? And so if you've got one item in it and you want to add another one in it, then the length will be 1. And that'll mean that when, again, 0 counts as a number. So the position that the new one will be added at, the second one, will be added at the 1th position. Make sense? So then we do gPointerArray add self arrow r comma item to add the item to the pointer array. And then what we need to do is, because the documentation says that people can connect to a signal called items changed, and so if people are going to expect when they connect to the items changed signal of our guy, they're going to expect to actually get that signal when the items change, and if not, they're going to get kind of grumpy. So we need to actually emit that signal, and we do that by using this built-in function. So you'll notice that there's no items changed as part of the vtable, so we don't have to create that ourselves. It's given to us by the GListModel functionality already. So we just call this function. We cast. I guess we didn't. Yeah, do we? Yeah, we do have to cast. We have to cast our guy to a plain GListModel, and then we tell it what position the item was added at. We tell it how many were removed, it's 0, and how many were added, it's always 1. We just hard code that because that's all we're allowing users to do. And last but not least, we have our constructor function, which really doesn't do very much except, and again, I've added a fix me because I don't know how necessary this is to do a gReturnIfFail, because we're already checking at the g paramspec level, but it doesn't really hurt, and I've seen other code do this, so I'm just going to keep it in. Again, make sure that when somebody says I want to create, what it does, I should say, is ensures that if one of our library users wants to create one of our list models and they pass some junk to it that is not a valid GObject type, it's going to throw an error and it's going to return null. So that's what that does there. And otherwise, if we've gotten a valid GObject type, then we're going to do this GObject new call, and which uses our guy as the GType, and this is where you add properties. This is where you instantiate, I should say, properties at the constructor stage, because type is a construct only parameter. This is the only time that it can be defined, and so we do that here. And for the purposes of language bindings, we can't just bypass the whole property thing and say, well, you know, demo GListModel star self equals GObject new demo type GListModel null, and then just go self arrow type equals type. As much as we'd like to be able to do that in C, and then get around having to implement properties, that doesn't work for language bindings, so don't do that. And if you want to know kind of a deeper dive as to why that's the case, Emmanuel Bossi has an excellent deep dive in the GObject ecosystem. A couple of videos you might want to check out. Okay, so now that we've got our list model type crafted, we're going to do a little demo program that shows how to use it. So of course we include our header for our demo list model. Now, because we are a little lazy and we're going to use a pre-existing object type to add, a very simple pre-existing object type to add to our list model called a GTK string object, and also we're going to be using it in the next episode too. So I figure we might as well start here with it. We do need to include gtk.h in this program because we want to use an object that doesn't exist in GObject or GIO. It only exists in GTK. So even though we're not creating a GUI, we still need to include that header, unfortunately. So let's work a bit, not backwards, but let's just, all we have is the main function and a callback. So let's just start with the main function. So what we're going to do is we're going to create a list model using the subroutine that we just crafted in our other guy. So the object type is a valid GObject, and it's called a GTK string object. And all it really is it's a string that's implemented as a legit GObject. There's something else called a GString. I think we might have used it before, I don't recall, but it's one of those guys that looks like a GObject but isn't actually a GObject. So we got this GTK string object guy to make our life a bit easier. And what you do is you create those types of string objects by doing GTK string object new and then a const char star to the string that you want to create with that. And then to grab the string, what you go ahead and do is you do GTK string object get string on that object, and then it'll return a standard C string when we need it. So that's pretty nice to have that guy pre-existing for us. So we're going to use gAutoPointer to show a few other things here that we've talked about before, but again, I just want to hammer a few points home here. So recall that the gAutoPointer will unwrap these objects when they go out of scope unless they're null or nullified, in which case it'll just do nothing by the time it gets to the end of the scope. And so the end of the scope here is the end of the main function, which is like not super useful because by the time we're at the end of the main function, we're exiting anyway and all the resources will be freed. But as an exercise, it's still a good thing to take a look at. So this will help us understand ownership and stuff like that as well as we go forward. So as we'll see, we will not want these guys destroyed at the end of the function unless something goes wrong or something like that, which isn't really handled here. But generally speaking, we won't want these guys to be destroyed because they're going to be added to our list model. And so we'll see how to address that in a moment. But this guy here is going to be a temporary string object that we're going to pull, and it's going to have an extra ref given to it, which I told you before happens whenever you use get item or GListModel get item, because it's transfer full. The caller owns the data and is responsible for freeing it. I should probably say freeing it, but anyway. So we have to free this guy. So we're going to use gAutoPointer to make it so that we don't have to manually do that. And then we're going to connect to the items change signal, which I told you about before. And just to show that it's working, I created a really simple callback that just prints out item added at position and then tells you what position it was added at. Easy. So since we know that our list model takes ownership of the objects provided to it, we're going to use gStealPointer here and do demo list model append demo : and then instead of just stir object 1, we're going to do gseal pointer the address of stir object 1, which will it'll do two things. It will pass effectively the address. Sorry, let me rephrase. It'll return the result of the address of stir object 1, which is just the memory address that is actually the pointer itself. But then it'll nullify the actual stir object 1 pointer. It'll set that to null. So what that actually allows us to do is it'll transfer ownership of the stir object 1 pointer to the list model, because it's going to get a perfectly valid address of the list model, and it's going to store it in its own guy, and then we're going to nullify the pointer so that when we get to the end of the function, it's going to say, okay, well, you define stir object 1 as an auto pointer, so we'll free it if it exists, but it doesn't exist anymore because it's nullified, and then so we don't have to do anything. And so the same thing happens with stir object 2. So effectively, we add the two string objects to the list model, and it takes ownership of those guys. So if we go gprint number of items in the model, and then call, we're going to use what do you call it, like a printf style function here, which is gprint, and then it takes we're going to pass a guint as the first and only parameter to what will be printed out. We just go ahead and call GListModel get n items, and we cast demo to list model, and then it'll hopefully print the number of items in the model, which will hopefully be 2 because we just added 2 right here. And then we're going to go ahead and grab the second or the 1th item and plop it in this variable, this temporary variable. Now, what we do is we call GListModel get item, and then we now have our own reference now to what I guess used to be stir object 2. So it's the 1th or 2nd item of the list model, but we don't have to free it. So it gives us an extra ref that if we didn't use auto pointer might become a memory leak if we forgot to free it. But we don't need to free it because we use auto pointer, and then we're going to print out what the contents of that are. And because you can't just do a %s and then pass a GTK string object, printf is going to have no idea what that is. So you have to use GTK string object get string to convert to grab the char star that is baked into that object, and it'll just grab that as a standard char star, and you'll be able to see what the string actually is. Now you may wonder, what's the point of going through all this rigmarole with the auto pointer and the stealing of the pointers and all that jazz? Well, in this simple instance, there's not much of a reason to do that. But if we had all kinds of code maybe between these guys, and if something went wrong along the way, it would be kind of a pain in the butt. You'd have to go down here and do like out : G object unref stir temp, and then somewhere along the lines over here, if there's a problem, like if you got all this code here, blah blah blah, and then something was wrong, you'd have to go to out, and then it would jump all the way down here and free. It's not pretty. So in this particular case, there isn't really like a necessity to do this, but it's a good demonstration. And if you did have more going on in between here, it does make your code an awful lot cleaner. And so just to show, again, to hammer the point home, if we now go ahead and try to access stir object 1 or stir object 2 directly, we won't be able to by the time we get here, or here, or in fact by the time we get really here, because ownership was transferred and the pointer was nullified. So if we try to do that and we go, contents of stir object 2 : %s, and then try to get the string of stir object 2, it's going to throw an error saying this is not a valid object anymore because you've passed null to it. It's not going to crash, but it'll give you an error, and it'll be printed on the screen, and we'll show that off now. All this stuff is being modified here. So we got a really pretty straightforward make file here. I just included the GTK library. It's just that we get everything all rolled into one. So just run make. It's going to build our main executable. Let's clear the screen just to make things a little more easy to see. We do /main, and you'll see, okay, the signal handler was, the callback rather, was called appropriately. An item was added at position :0, an item was added at position 1, and then by the time we added the two guys, the number of items in the model was 2, and then we used our temporary variable as a, we used our temporary variable as a way to temporarily grab a ref to the string, which was the second or the 1th item in the list model, and we printed it out. We didn't need to free it because we used auto pointer, and then when we tried to print out the nullified strobj2, this is the error that we get. It's a critical. It tried to get a string which was not a string because it was a null, and then it goes ahead and prints null in brackets to show that the contents of strobj2 are null. I think if you use printf, it might just crash, whereas gprint handles it gracefully. So there you have it. I know that it is a fair bit to take in, but it does really help to have an understanding of how interfaces work for sure, and then how list models work, because in the next episode we're going to be talking about list views and column views in GTK. So it really does help to have this sort of base knowledge before we move on to that. All right, hopefully you guys found that useful. This is Elliot Rathbone signing off. Good night and good luck.